Hey guys, welcome to school, the lab. I am here because I am going to film an experiment for you today. I couldn't find a cool, easy one for you to do at home, so this is the next best thing. The experiment that we're going to do looks at an enzyme that is found in potatoes. I've already chopped this potato up, and how efficiently it breaks down hydrogen peroxide. I believe the enzyme in the potato is called peroxidase. And so you've already learnt that enzymes work optimally at different pHs depending on where they are found in the organism. And that is what we're going to do with this enzyme found in this potato. We're going to figure out what pH it works best at, or on the other side of that, which pH denatures this enzyme. So remember, enzymes are proteins and they can be denatured or deformed if they are not in their optimum pH or temperature. And so this one here, this experiment is from your SciPad. I'm literally just following it along the same way that you would. It says changes in pH can denature proteins. Different enzymes work best at different pH values. The optimum pH for an enzyme depends on where it is found in the organism. Literally just said that. So the aim of this experiment is to investigate the effect of pH on the enzymatic breakdown of hydrogen peroxide. So here's hydrogen peroxide. This would be the substrate, and the enzymes are going to be from the potato. So first thing that we needed to do was we needed to get 3 test tubes and label them as acid, water, or base, because we, of course, are testing pH. And I haven't really labeled them, but this one here is our acid. This one here is going to be our water. You might just be able to read distilled water on that. And then this one here is our base. And the acid is just your classic hydrochloric acid, and your base is just your classic sodium hydroxide. Now, what I've already done is I have chopped up the potatoes into kind of equal sizes. I'll insert a picture here. As you can see, they're not really equal. I couldn't find any of the equipment that I needed, so I just did it with a really blunt knife. What we had to do was crush them up. So here's a mortar and pestle. I've actually got my third one in here. I've already put the crushed potatoes into the first 2. So this is our acid one, this is our water one, all nice and crushed up. And I've got my third one here, pretty much done. There's just a big lump. Yeah, I'm pretty much happy with that. And what you're doing by crushing it up is you are breaking all of those strong cell walls. So you know how plants have got these rigid cell walls that hold everything in place? Well, by smushing it up with the mortar and pestle, we are breaking those cell walls and we're releasing all of the contents out. So all of the organelles, the cytoplasm, but importantly, what we want is the enzymes. So we're releasing the enzymes, and now they're all in this sludgy, potatoey mess, basically. And it's a little bit messy trying to get them into these tubes. Bear with me. Okay. So that's pretty much in there. So now we have got our acid one, our water one, which of course pH of around 7, and our base. Now we'll just get you down to the bottom there. Okay, next step. Add a few drops of dishwash liquid to each. Okay, so here's our dishwash liquid. What this is going to do is if we see any foaming occur in the reaction, it's going to indicate that the enzymes are working, or that the enzymes are breaking down this peroxide. I'm just going to add a couple of drops. Going to try and keep it as equal as I can. 1, 2, 3. 1, 2, 3. Okay. Next step. Add 10 milliliters of hydrochloric acid to the boiling tube. Okay. So here's our hydrochloric acid. Oh, it's a little bit much. I'm going to pour it in here. being very accurate, reading the meniscus on the measuring cylinder. Okay, that's 10 milliliters and I am just pouring it in. Okay, I'm probably going to cut now to me having already have done that. Alrighty guys, so I have added 10 milliliters of hydrochloric acid, 10 milliliters of water, and 10 milliliters of sodium hydroxide to each of these boiling tubes. Now what it says to do is just wait for 3 minutes and then add 10 milliliters of hydrogen peroxide to each tube. So I'm just going to cut to 3 minutes later. Okay, it's been 3 minutes according to my phone. I think the reason why we are leaving this for 3 minutes is because we're really giving enough time for the acidic or the neutral or the basic liquid to come in contact with the enzyme, so we can really see if those enzymes are going to denature or not. Now the next step is to add 10 milliliters of hydrogen peroxide to each of these tubes, and I've already measured out 3 separate boiling tubes, what are they called? Measuring cylinders, so I can do it quickly. So once we've done this, we have to observe. So I'll probably bring this test tube holder up so we can see what's going on. So adding to the acid, adding to the neutral water, and adding to the base. Wow, we're already getting a reaction. So this is our acid, this is our water, this is our base. Can you see the height of this foam in this base, neutral water? So what this is telling us, of course this is from the detergent that I put in, that's what's actually creating the foam, but this is telling us that the enzymes are working really, really well at this pH of about 7. They're breaking down all of the peroxide that was in that hydrogen peroxide. I think this is going to overflow. And we've essentially had no enzyme activity whatsoever in the acid or in the base. There's just nothing going on. There's a tiny little bit of foam, but I think that was there to begin with, to be honest. So I'm going to leave that here. So what I want you to do is suggest a possible explanation for these results. And in your answer, I want you to use the word denaturing. What can we say about the enzymes in the potato? What type of pH do you think that they would work best at? And think of a potato in real life. Think of it growing in the ground. What would be its optimum pH for those enzymes working away, breaking down substrates, building up substrates? Okay, bye guys.